Ultimate Altera. Hello, my name is Devendra Anadu, son of Rajan Anadu. My metric number is 193479.
Hello, my name is Shanmugha Prasad, son of Nagaratna. My metric number is 194904.
And today we are accepting challenges for our Altera project. So here, of course, we have the Altera board,
And here we have already have quarters 2, edition 13.0, reloaded.
Yeah. So let's, without further ado, we will be accepting calls. So anyone out there who are willing to give us a challenge, please do give us a call right now. We'll be rating any moment now. Oh, that's a quick one there.
Hello.
Hello, who is this?
My name is Tom Cruise from Hogwarts University.
Hello, Tom Cruise. Please, what do you have for us today?
I've been stuck in my project descending 5 to 0 using 7 segment. Would you guys help me out doing that project?
Sounds easy enough.
Yeah, sounds easy enough. Not bad.
Let me try in quarters.
If so,
Let us try.
I'm looking forward from you guys. Thank you.
Yes, thank you, Mr. Tom Cruise. Thank you very much. So let's begin.
Yeah. We should declare button, and the input is 7 bit. The output is a 7 bit.
Yeah.
And the input is 4 bit.
4.
Okay.
Welcome back. Now we introduce to you
The amazing,
the marvelous,
the greatest,
the one and only Altera, brought to you by Shanmugha
and Devendra.
Hello, it's me again. So let's move on to the coding that we have done for Mr. Tom Cruise. So first, I've named the module marked _3 and I've declared on, off, click, reset, 7 segment and also LED, which the inputs are clock, reset and on off button. The output will be 6.0 is 7 segment, 0, 1, 2, 3, 4, 5, 6, which are 7, and also the output register for the LED, which are 0, 1, 2, 3, 4. Don't forget that. And the register delay is 28.0 is the delay. Why I use 28 is because 28 bit is needed for 100 mega, which will be the delay for 2 seconds, because the clock that I've used, the pin is 50 megahertz. So next is the wire toggle. We'll tell later. And also the next is always post H clock and post H reset, which means the square wave I've used, meaning it will only be effective on the positive edge of the clock. So let's begin. First, when it's reset, the delay will begin to 0, which means it starts over. And also same when the delay is 100 mega, which we want, it will also return to 0, which also we want. It means it starts to delay, and when the button is turned off, the delay will then become delay plus 1, which means the delay will keep going on once the number increases. And the assign toggle, which is delay, when the delay is equal to 100 mega, which we want for the delay, the input will be at input high, meaning the delay occurs, and when it's not 100 mega, it will be at input low, which means the delay does not happen. So let's scroll on down to see more. So next will be the always post H clock again, which I'll be used, which means the positive edge of the clock. And when it's reset, of course, the LED will indicate that it's 0101, meaning it's number 5, which just what Mr. Tom Cruise needs. Descending from 5 to 0, and once it happens, it ends. And when the switch is turned on, that means toggle. Toggle meaning which I have mentioned just now is the delay will happen, and when the delay happens, and then we have to begin the counter. The counter when it's at 0000, when LED is at 000, which means the binary 000, and at base 10 it's zeros itself. Then the LED begins to start the counter, starting from 5. The counter is mentioned here, else, where it is LED equals to LED minus 1. That's the descending counter from 5 to 0. And then this is the end for all of these statements. And then finally, the statement here, I've mentioned their segment in bracket 0.7 segment, and in bracket itself segment 0, which means I have mentioned the call function for the 7 segment, which will be explained later by Shanmugha. And also here BCD itself, which is in the brackets of LED, which means the input of LED is the one that will be used for the BCD input of the 7 segment. So let's move on to Shanmugha.
Okay, let's begin with the line number 44. So this segment 0 is a module name, and in bracket there is 7 segments in bracket seg0 and B.BCD and LEDO. So these 7 segments are the defined, the declaration, and the segment 0 are represent. So it means the 7 segments are represented by the seg0 in previous coding. So same as LED, and we just move on to line number 47. So module date it's a name, it's just module name, and 7 segment in BCD is defined in the coding, and we set the input. We input BCD, which is 3 to 0, which means 0, 1, 2, 3, which means we have a 4 input, and the output are 6 to 0, which means 0, 1, 2, 3, 4, 5, 6, which is a 7 output, because we are using a 7 segment. So it have a 7 segment. 7 segment will be light up to show the display, which means 0, 1, 2, 3 like that. So let's move on to the always. Always in strict means it represents the input. So we begin the case BCD, and this is the input and this is the output. This is the input and this is the output. Then when the input are 0, 0, 0, 0, when the it means the BCD, when the BCD are 0, 0, 0, 0, then the output are 7 segment, which is 0, 0, 0, 1, which is represent 0. So we will continue until it will display until 9. But for this coding, we just setting at the upstairs until 5, which means until here it will display 5. So let's move on. So and finally we default 7 segment, which is active low, which means we using the coding, we using the 7 segment cathode. So means we set there's active low, but when during the declaration of this number, we just change 0 to 1 and 1 to 0, which means we say that the 7 segment are active cathode. So now we see the pin planner for this hardware for our coding. So the first one is clock. We set as L1. The clock is, why we choose the L1 is because it's used 50 megahertz. Then we just take the data sheet from the DE1 and we just place it. This is Y19. This is a 4 input. This is Y19, U19, R19, R20 and L20. This is the 2 input. This is on off button. It's the L22 and L21. Then this is the 7 segment output, which is the L. There is a 7 segment will light up due to the condition. That's all for pin planner. And let's move.
Welcome back. So
now we with the hardware.
Yes, and we will be uploading the program
So
for the demonstration.
in front of you guys.
This is the coding. We have explained this now.
And we want to compile now.
Let's begin compiling. Compile.
So the compile process is going on.
And now it's still going on. That's 34% of that. Yes, being successful.
Sure, the compilation will be
Successful,
because the coding is ours.
Yeah, of course.
Okay.
And
the
there
coding
it
was
is.
successful, and we just directly go to the pin planner.
And of course, the pin planner we have explained as well.
Yeah.
So let's begin compiling.
Compilation.
Yeah, compile.
Okay,
And
done.
it's again successful again.
Then final part of our presentation.
Oh God, yes.
This is upload the program into the hardware, and the hardware will display the 7 segment. So
Let's begin.
okay, successfully, and this is the on-off button, and this is the reset. We already set in the pin planner, already explained by Devendra. And I just on the button. Okay.
Yes.
5, 4, 3,
2.
1.
No, it's still 2.
Oh,
1.
Sorry, it's okay because
0. Yes, successful.
Delay was
Let's
2
reset.
seconds.
Can we
so,
reset it and
Yeah.
reset?
So the delay was the 2 seconds. So that's the problem for the number move is late a bit. It's 2 seconds.
2 seconds. So that's what we said.
That's
But
all.
we can change to 1 second.
Yeah,
that's
that's also can change.
So, Mr. Tom Cruise,
I hope you get.
hope this helps and
I
you
hope this is get for you.
Yes.
And this coding is for you.
Yes, this is for you, Mrs. Tom Cruise.
Thank you.
Thank you very much. And thanks for watching our show.
So, yeah.
And this show is called Ultimate Altera. Thank you.